Okay, well, I labeled this as an intermediate develop, but I think it might be a bit more advanced. So if you're not asleep yet, be prepared. So my name is Trevor Vaughan. I am one of the owners of Onyx Incorporated. We are a government contracting company like everybody else around here. And we do a lot in terms of systems automation in terms of large-scale system deployments and security. So enough about me. We'll get on to talking about other types of providers. So what we're actually doing, we're going to go through how you can actually go through this with me on your laptop here. An introduction to types and providers, a basic type code walkthrough, basic provider code walkthrough, type execution order, and provider execution order. This is all important if you want to actually create custom resources of your own for doing more advanced types of management of your systems. So if you're writing a lot of execs, this is what you're going to want to look at to replace those execs with native Ruby code that's more efficient and effective on your systems. Oh, and feel free to call out questions because we're actually going to be going through a code walkthrough and it's going to be relatively dense. So you can follow along at home. You can snag a copy of the walkthrough code from our Git repository. We have the commands here. I was hoping there'd be a chalkboard, but there wasn't, so type really fast. And but you have the shortened URL on the top right. And this whole presentation is actually released under Creative Commons, so you can fork it, clone it, get back to it, whatever you like. So what are types? The basics of types. For those of you that don't know, types and providers are what you use, are the fundamental building blocks of your system resources. And yeah, you can correct me if I misspeak or anything. As Kara said, I put this together about 2 days ago, so we'll get there. So that they consist of properties, which are something that can actually be measured and changed on the system. Parameters, which change how Puppet manages resources through the properties. So they're more like variables in your system instead of something you're going to look for on the system. A validation portion, so anything you need to do to actually validate that your resource is effective as you're applying it to the system or creating it on the master. And an auto-require section, which lets you require other catalog items without actually needing to worry about them being defined. This is particularly powerful in that normally when you have a requirement statement and your manifests, both of those resources have to be defined in their catalog. In this case, you can actually set up a requirement statement such that you don't actually have to have everything you require in your catalog. You'll just require them if they happen to be there. Confused? Good. So right there, it does not actually require the resources to be defined. So what are types? The advanced portions. We have an initializer, like most Ruby objects. This provides you the ability to manipulate the resource, your resource mid-compile. What that means is you can actually go through and adjust your catalog as your resource is being created. I'm not sure you guys exactly want people to do that, but it is possible. There's a finishing statement, which is anything you want to do after your resource has been compiled. So at that point, your resource is in the catalog, and you can adjust the catalog around your resource. And post-resource evaluation, which actually is brand new and allows you to do much better resource cleanup than in previous versions. And this is available in Puppet 3, 4, and later. So what are providers? So that's the types portion. And like I say, resources are made up of types and providers. The provider portion is how you actually apply the state to your system. It also has an initializer, which is a place to do anything you want to do that's going to persist across your entire provider. Be careful with this because this does go into a higher namespace in Ruby, which means that you may end up affecting the state of other resources in your catalog if you're not careful. You have property methods, which are automatically referenced methods for manipulating properties on the system. So, and we'll get to that later. It all makes sense sometime in the future. And then there are miscellaneous other things you can define in there, pretty much any method you want, and you can call those from your type or other parts of your provider to affect the state of your system. And you're probably all looking at me like this. And yes, I'm a classic fan. So, all right. So here we have a basic type scaffold. You have your initializer up here, as I mentioned. You have your finisher here. And right now, all we're doing in the initializer and finisher is calling super. You definitely want to do this, because if you don't do this, what's going to happen is your your type is not going to be initialized properly in your catalog, and Puppet will yell at you and fall over. A parameter, which is name, it's kind of a default. All resources in your catalog need a name. Again, if you don't have a name bar, if we're calling your name bar here, it is name bar. If you don't have a name bar in your catalog, again, Puppet will complain and tell you you have to have a name bar in the resource. We have one parameter foo, which says foo, and a property. Our property is baz, and our other parameter is bar here. This ordering is very particular to this example, in that we have two different parameters that are surrounding a property, and that's to show the order of execution during the actual run of the catalog. So we have, right now we're not validating anything, we're just saying, I'm just showing you that we have a validation portion, and we're returning true, which means everything validates, life is wonderful. And we are auto-requiring a file resource type of, you have to return an array to this, and this is going to be the file temp foo. So if we happen to have a file called temp foo in our catalog somewhere, then this type will require that resource that's already in your catalog. And if you don't, this causes no errors, everything's good. Make sense? Good. All right, so here's our provider scaffold. You can see here we're actually telling, so I should have covered that. So our new type here is X order, example ordering. And here we have to bind this provider to our type, the type X order. The provide statement here, as far as I can tell, is arbitrary. Can you confirm that?
What do you mean?
So provide Ruby, you can call that provide foo, provide baz. It doesn't really seem to matter. It needs to be right. So it is an arbitrary name, but it has to be unique for your provider. Here we have this is going to get you in trouble, but here we actually have a space at the top level of your provider, which is a class variable, which is assigned to a hash. So this class variable can actually be accessed through your entire provider. You're very, very careful with this. In Ruby 1.8, it works great. In Ruby 2.0, it really doesn't like this, and it will give you hundreds of warnings every time you run Puppet. But it can be very useful in terms of actually trying to build resources that apply once across all definitions of your resource. That's a different talk. So here we again have an initializer. You pass it an argument reference, and then you call the superclass with the argument reference to make sure you don't actually lose any functionality from Puppet itself. Okay, so previously, if you remember, we had a property baz. And this definition baz is automatically called to retrieve the state of baz from the system. So if baz happened to be a password for somebody's account, then this would go in and have the logic in it to go retrieve that password from the person's account and send it back to Puppet for comparison. And then you have baz equals. So baz equals will go and set the value on the system after the comparison has happened. There's also an nsync define. However, that can't be placed into your provider right now. That has to actually go back into your type under the property. So we're not covering that right now. What nsync does is it takes something called is, which is what this returns. So it takes the return value of the baz definition, and then it compares it to what it should be, the variable that you pass it inside your resource hash. If those two differ, then this definition gets called. If they don't differ, you are in compliance and this resource is done. And then we have a flush. So if you have multiple properties on your system, or just one property, then any of them are out of sync, the flush method gets called. So that means if you have 15 different properties and only one of them is out of sync, then flush will get called and you can apply the logic for all of your properties and all of your parameters all at once. So this is our sample manifest that we're going to execute. Again, this code is online. You can download the running code. You can try it on your laptop and watch the entire output here from this presentation come out on your home system. So right now we're going to create one resource, xorder test. So remember, our type was called xorder. So we now reference it as xorder just like you would file, package, etc. It's called test. That's our name bar. We have the options foo, bar, and baz, and we're calling them foo, bar, and baz. Okay, so again, full execution walkthrough. If you want to, you can find all the code and output at this location. This presentation will be online, and this code will be locked up on GitHub. so you can get it at any time. All right, so the way I set up the slides is over in the left-hand corner here, I'm showing you where we are in either the type or provider, because Puppet jumps back and forth between the two as it executes. And then here, I'm describing what section we're actually running through. So right now, we have the name bar again. Now we have something inside the parameter foo, which is stating that parameter foo is starting. We have the property baz, which is going to give us, and so I'm using puppet.warning just so we get nice output as Puppet runs. You wouldn't normally do this in your manifest unless you were actually throwing a warning to the system. So we're going to say the property baz is starting, and then parameter bar, we're going to say parameter bar is starting. So the output of this, if you just run this with our previous manifest, is you'll get warning, param foo starting, property baz starting, param bar starting. So what should we expect? Again, if there are any questions, call out. I'm going too fast, call out. I'll talk really fast. So here again, so now we're in the provider. So we move from the type into the provider, and we're now covering the globals inside the provider. So here again, we have the global class variable, X order class bars. Again, if you ever use this, make sure it has a unique name across the entire namespace of your whole system. And then I'm saying that this has example true. And I've now added a warning at the global level of the provider, setting property class variables. So the next thing you would see after the previous output would be setting property class variables. So now we've gone into the provider, and Puppet has initialized the provider, or created the provider. So now we're back in the type. Like I say, it jumps back and forth a bit. So we're back in the type. We're going to do name parameter munging. So we're now here in the name parameter. It is still name bar. And we're going to say, hey, the value that you gave me for the name, and I'm in the name parameter. So if you remember in the resource, we call it test. So it's X order with the name test. And you can see in the output here, warning, test, and the name parameter. So now Puppet knows about the actual name parameter within this namespace. So now we're back in the provider, and we're going to initialize the provider. So we've gone through the globals in the provider, and now we're going to initialize the provider. So right here, I'm in the initialize definition. Make sure you call super at the top of your initializer. If you don't, things can happen incorrectly. So then we end up with these three warnings. And you can see here, I'm actually calling resource name, resource foo, and resource bar. But remember, we've only gone through the name parameter on the system. And this means that inside of, even though this is in the provider, we only know the value of the name. So we know the name is test, but we don't know the value of foo and bar yet. So ordering does matter. This is very important when you start trying to manipulate your data structures further inside the code. So here we're back in the type. I'm reminding you of the order of our parameters and properties here. And again, I did that on purpose to show how it works in the examples. And we're in the property baz. So properties and parameters all get evaluated in the order that you actually write them inside the manifest. So, but properties happen before parameters. So do property baz. We're validating. We can get access to the resource name now, which is test. And I am showing you here that even though parameter foo is defined before property baz, you can't actually get access to that because parameters are evaluated after properties. So again, if you're trying to do fancy things with validation and munging, it's just important to know that that's going to trip you up and basically know these orders happen. So property baz, validating, and foo is blank, because we have no idea what it is right now. So now, we're still on type, we're going through parameter foo. So now we're finished with our properties, which is baz. Now we're starting over at the list and going down all the parameters. So we're going to hit foo first, and then bar. So we're here, we're doing the same thing, we're validating foo, we're giving you that you still have access to the resource name, and that we are in the validation phase. Down in munging, you'll also notice the validation always happens before munging. So if you're trying to manipulate your value later, whatever the user passes in will get validated by validate, But then you can transform that into something else that suits your needs. You can transform it into a hash, an array, you can change strings to integers, whatever suits your need for comparison later or application to the system. So here we have access to the resource name, and we have access, and of course we're printing out the munging message. And I'm showing you here, since bar is below foo in the execution order of the type, we don't have access to bar yet. So we see that foo is validating, we see that foo is munging, but we still don't have access to bar. So, still in type, now we're in parameter bar. So that's our last parameter. We've gone through foo, we've gone through bads. Same code, and you can now see that we do actually have access to the foo parameter. So if you have something you need to, like if you have a path or something, you need to pull out 2 different variables, you can do it by declaring the base path first, and then declaring the target afterward. And then you can actually put that together in your munge statement so that your Puppet resource actually applies to the correct path on the system. So here we're validating, we're munging, and we can now see that the value of the parameter foo is indeed foo, as we stated in our example manifest. And yes, order matters. All right, so is everybody, am I going too fast, too far? Yes?
How performant is that? It seems like it's a lot of...
So it's actually very performant. This is the way all resources inside of Puppet are evaluated, including the native ones. So basically what I'm doing is I'm showing you how everything in Puppet works by default. Some types have been written in different formats. So some people will do automatic creation of resources, automatic creation of different aspects of the code. But if you want to make it really, really easy to follow for people who have to maintain it later, if you do it like this is just how it works. And this is validated against the 2.x series and the 3.x series of Puppet. So back in the type, we're going through our validation phase now. So we've done our initializer on the type, we've done our properties and parameters, and now we're going to hit validation. So here I'm saying that we have required parameter, the foo, bar, and baz. So by default, nothing in Puppet is going to be required, or no properties or parameters are going to be required except for name. So you actually have to write code to say, I want you to put something in here. So here I'm saying that we're in test, and we're validating. And I've given you an example here of how you can actually tell people where they have an error. So if you notice, Puppet will generally give you a message saying, hey, I failed on line X in file Y. And so if you want to do that yourself, then what you're going to say is, if I don't have this parameter defined, then raise Puppet parse error, self file colon self line. So that'll tell you exactly the line of file that your resource failed on. And the output is, as we expect again, param bar validating, because we did actually define all of the bar paths. All right, so I'm sure you're all asking yourself this question right now. And the answer is this. Forwarding post. So now after we've done everything in the type, now we're going to initialize it, because that makes sense. It's completely backwards, and I don't know why I haven't asked you. So again, in the type initializer, you want to call super to make sure you're actually getting everything the Puppet wants you to get, all the magic that happens behind the scene before you do your own work. So here I'm telling you, I'm going to print out that we're initializing. So here what we're doing is we're actually showing you how to delve through the entire existing catalog, because remember, all your properties and parameters have been run through. And here you can actually go through the entire catalog as it's compiled up to this moment. So that means anything that comes after this resource won't actually be referenced in this return array, but you can go through everything that's already been in the catalog. And count, like here I'm counting the number of things that are of type X order. And I'm printing out X orders in the catalog are this number. So here, we say we're initializing, and right now we have one X order in the catalog. So if you went through and you defined 58 X orders, then as they executed, it would print out 1 through 58. showing you that it actually knows what's in the catalog. Other things you can do here include actually manipulating your notify statements so that you can have explicit notifies, because we have auto requires, but we don't have auto notifies. Unfortunately, when you do this, what happens is it does actually require the resource to be in the catalog. So you have to be a bit more careful with that. We do have a bug report file that actually auto notifies them so that you don't have to have something in the catalog, but it will automatically notify it. So you get the inverse of the auto requires. So now that we get the initializer, we're going to immediately jump to the finisher. So it is a statement called finish, a define called finish. So we're going to type, we're hitting finish. We're going to print out the public warning, self-name, type finishing. And in this case, you want to make sure the super statement is actually called at the end. And the reason for this is that Puppet does some catalog finalizing at the very end of the resource run. So if you call that at the beginning, then everything you do after super may not actually happen inside your catalog. And we get, of course, type finishing. I'm running far too fast, so I care. So here, so we're still in the type. So after we've done the initialization and the finishing, now we get to the auto requires. Oh, yes, sir.
So for the initialize and the finish, aside from notifications, what are some real world, what are the other use cases for it?
So if you look at the DataCat, so there's a concat module that we came out with, and there's DataCat, and I can't remember the name of the gentleman right now, but you look at DataCat, what he does is he has a file, basically a file piece builder, and he has a file collector. And in the collector, it actually runs through the catalog, and it gets the data out of all the different resources that were defined in your system for those portions. And so in memory, it can put a complete file together based on resource fragment declarations. So that's something that you can do in here. It's very powerful and very useful. So let's see. Right, so here in the auto requires, as you would expect, we're going to print out an auto requiring statement for our files, just showing that we actually executed this portion. Auto requires, unfortunately, there's really nothing preventing you from doing bad things in any section of this. You can do things in the initializer, the finalizer. You can actually manipulate things inside of the auto require statement. Again, I don't recommend it for readability and understandability, but it is possible to do. Yes, sir.
So does the auto require take care, I guess, when other manufacturers is required, like you said, you want to require a specific package?
Yeah, okay, so the question was, does auto requires take care of the situation where you want to do your requires in your manifests? And the answer is yes. So what this is doing, so in the case of users and groups, so if you're adding a user, you want to add the group for the user automatically, right? So if you define a group and you define a user, then there's going to be an auto require statement in the user that says, hey, if the group happens to be in the catalog, then go ahead and require that group from my user without me having to actually do anything. So again, this makes it really easy for you to make sure that your users don't have to know every single intricate detail of how your custom modules work. So that's really what it's for. And yes, like I say, I really prefer this to doing the explicit requires when possible. You do have to be careful though, because you can run into situations where if your titles are too generic, then somebody else could come along with something of a similar name, and you end up requiring something you didn't want to. Does that make sense? All right, so now we're actually done with the type, and we're jumping over to the provider execution. So we're going to start in the BAS getter. Again, we have one property, which is BAS. So the first thing the system's going to do is run through the properties and run all the getters. So here, oh, pardon me, no. It's going to run through each property. It's going to run the getter, in-sync, and setters for each property in sequence, and then record that. So here we have the BAS getter. And basically, if you look at the in-sync statements, there's something called is and should. The result of this is going to be what the is variable ends up as when you hit in-sync. So I'm saying a public warning, resource name, and getter for BAS. So again, what this may do is if you were trying to validate a password on the system, it might go to SE password, or SE shadow, and pluck out your password hash and then store it in memory so it can be compared later. So then we hit BAS and sync. BAS and sync, as I said, is one of these things that should be able to be placed into the provider, but it currently can't. So you actually have to go back into the type and put that inside of your property. If you want something besides the default, and this is the default. The default is just, it is equal to should. That's it. And most of the time, that's probably what you want. But if you get into some complex scenarios, you may end up needing to manipulate should. So say you get a host name back from should, but you need to compare it to an IP address. So you're saying, am I actually this IP address? So you get is, which is the IP address. You get should, which is the host name. And in here, you would actually go resolve the host name and compare the two IP addresses that you get back. That way, it's your definition of in-sync. So here it gets a little strange as well. If back in the provider, you may have noted I was using just plain resource name. Since this is actually in the type, you're going to need to reference the instance variable resource. Just because, actually I'm not quite sure why, because I don't understand the internals that well, as well as I should, but you do have to do it. So saying we're here, we're in sync for BAS, and right here, it comes down to whether you return true or false. NSync is a pure Boolean. If you return true, you're in sync. If you return false, you're not. So all the logic you have in here just comes down to returning true or false. Here I'm returning false, just so you can see the execution of the rest of the provider. So here, test NSync for BAS. So now, since we were not in sync, we get the setter in the back in the provider. So again, it's BAS equals, so you're actually overriding the equal statement for BAS, and you're saying that if NSync is false, then call resource name instead of for BAS. And here again, stage main, exporter test, BAS change test. So again, like you would normally see if you were changing any other resource on the system, you're going to see the resource name, and then you're going to see a statement. And so the original value was BAS, so BAS change test, and getter for BAS to BAS. Yes? So
Is that the munch value or the initial value that shows up there?
that would be munch value. Yeah, the munch, actually wait. No, that is munch value, because it's just the is and should. So it would be the should value. So now we're in the flush section of the provider. And since we had a property that actually was manipulated on the system, then the flush statement is going to execute. And this would happen if you had 15 different properties and only one changed. Flush is going to happen. You have 15 changed, it's still happening. So as long as only one change, as long as one or more change, you will hit flush. So here I'm just, in this case, I'm just saying time to flush resource name. A lot of times what this is used for is cleaning up any class variables or storage state that you will have built during your resource. So, and this is the piece that was actually added in 3.4. You get the post-resource evaluation. So this means if we had 15 different X-order resources, this would execute once after all the resources have been executed. And again, this is really good for, this is what you need for cleaning up local state. So here, self post-resource eval, and I'm printing out the word this to note that we are actually done, and you all are free. So of course I had to put in something with Zelda because, you know. So are there any questions? Tomatoes? Yes, sir. No shoes. I'm going to carry the microphone, she'll yell at me.
You all waiting? You're so good, you're so patient. Where am I going?
I'm curious if you could talk about situations that you've come across in the past where this is necessary. I mean, I know there's a lot of stuff that's already been implemented by Puppet. you certainly want to use those if they're there, but could you give some examples?
Absolutely. So really, when I started creating different modules, I would notice that I had a lot of execs laying around. And execs are very expensive on the system. They're not horrible, but again, you're calling out the shell. And what you'll start to notice is well, I'm doing this exec, but I'm going to chain this exec to the other exec. And then later on, I'm going to have an if statement that changes this other exec back to those previous two execs. You end up with this big, mess of just execs and ifs and elses and everything else. And you also, whenever you run Puppet, now you're watching things that might run every time. So you're getting output every single time Puppet runs because you have an exec that you need to run every time. Or you're starting to put only ifs in all your execs and doing really crazy bash code to make sure this exec will only fire off when you're supposed to. So in those situations, you really want to take it and collapse it up. And that's when you really want to create your own custom text and providers. Because you can take all of that logic, put it in one place, and you can get better reporting, you can get better analysis, and honestly, your code just gets a lot more compact and easier to maintain.
Just as a quick follow-up, how stable is that API been over time? And I guess
Well,
like how far back do you go for writing your own modules?
Well, it's been there since 0.24, so pretty darn. So again, this isn't a module construct. This is a basic resource construct, and I've been using Puppet for about 7 years, and it's been working the whole time. So don't look at the early modules, the early providers. Look at the new ones. They're all good.
So I saw a lot of, I guess, internal types of providers. But what happens when you do external, like a network connection out? Where do you actually put those Ruby gems? Is it providers or the pipes?
So so you're talking in terms of gems or just connections out to the system? Okay, so since this is pure Ruby, you can include any Ruby gem that's on the system. So it has to be on your Puppet client because all of your resources are going to execute on your clients. So say you had a network management node that is not your Puppet master. Then what you would need to do is make sure that the correct Ruby gems are installed in your Ruby path on that client, on the network node manager, and then you would execute this resource on that network manager.
Is it in the provider file or the pipe file?
In the provider. In the provider. So the provider is what is going to do the work on your system. Anybody else? No
Yeah,
problem.
good one.
For prefetch and the instances, aside from that book right there, is there any other documentation out that details that?
There is my wiki, which is this presentation in wiki form. So the reason I actually wrote that wiki was because I didn't find any good documentation on exactly how things executed. There was documentation on what to do with the pieces, but not exactly what happens top to bottom when you're executing your own custom types of providers.
Anything else? Thank you so much, Trevor.
Resources to the presentation, and I wanted to remind everybody, I started the Baltimore Puppet Users Group. Please join us June 25th. Kara knows everything. It's good. And since this presentation is open source, I have to give reference to the guys that created it. Good stuff. Real JS. Thank you.